Okay, today we're going to do quick video notes on 6.3B Day 2. It's basically our second day of graphing quadratics in standard form. You have this filled out on the sheet. This is the same thing we filled out on the sheet the other day on day 1, and we're just going to be focusing today on standard form. Let's review how to graph in standard form in example 1. So we're going to graph y equals negative x squared plus 2x plus 3. The first thing we wanted to find was the axis of symmetry. We know that for the axis of symmetry, we use x equals negative b over 2a. Our b, we know, is the coefficient of x, which is 2. Our a is the coefficient of x squared, which is negative 1. So we have negative 2 over negative 2, which gives us 1. So our axis of symmetry is that x equals 1. That's going to be a line that it looks like we're going to be able to fold the parabola on. Okay, and so we can put that on our graph. I know I'm rushing a little bit. I'm just trying to help you guys get more time to start your homework. So now for our vertex. For our vertex, we're going to put 1 in place of x to help us find y. We know that. So we're going to have negative 1 squared plus 2 times 1 plus 3. We discussed just putting it in the calculator with all the different parentheses that we're going to need, okay? And we find that that value gives us 4. That tells us our vertex is 1, 4. We discussed the other day that we put the vertex in the middle of our table. And we only need to fill out one side of the table because of symmetry. And a nice point to look at is the y-intercept. Remember, the y-intercept occurs when x is 0. And in standard form, when x is 0, we can just look at our c value, which is 3. Our y-intercept is 0, 3. We discussed deciding what side that should go on. Well, 0 is less than 1, so let's put that over here. And then we can fill in another part to make sure we have a nice shape. And we have negative 1 we could put in for x. Once again, we would just put that in place of x in our equation. Negative x squared, so negative 1 squared, plus 2 times negative 1 plus 3. You can put that in your calculator. Again, I'm just trying to save time. You get that that gives us 0. So let's plot these points. Negative 1, 0, 0, 3, and 1, 4. Again, don't have to fill in the other side of the table because now we're just going to get those points by reflecting over the axis of symmetry. Our vertex is on the axis of symmetry, so it doesn't reflect anywhere. This is 1 away, so we reflect it 1 away. This is 2 away, we reflect it 2 away. And now I can connect these points to make a beautiful parabola. And that's exactly what we did in our last day of notes. So now we're going to look at a little extension. Notice there's an extra question here. It says, what are the solutions of negative x squared plus 2x plus 3 equals 0? Well, notice the only difference between these equations is that this is a function involving x and y, and this is just an equation with x, and it's equal to 0. So the solutions are going to be when y is 0. Remember that we can look at the x-intercepts of the graph, and that tells us when y is 0. So basically, to find the solutions, you're going to look at the x-intercepts. So we'll make this little note. What are the solutions? We'll say, well, the x-intercepts are at, let's see, negative 1, 0, and 3, 0. Make sure you count from the axis, 1, 2, 3. So if those are the x-intercepts, the solutions are those x values. The solutions when y is 0 are x equals 1, x equals 3. And that's really the only new part of what we're doing. We're going to look to see where the graph crosses the x-axis. Those x-intercepts are the corresponding solutions to the equation. Okay? Let's do the same thing in example 2. All right? So we'll find our axis of symmetry. Our x value, we would take negative b, so negative 4, over 2a, so 2 times 1. That gives me negative 4 over 2. So x is negative 2. So that's my axis of symmetry. And we can put that right on the graph if you'd like. So always start with negative b over 2a to find the axis of symmetry when it's in standard form at this point. Now to find our vertex, we're going to put negative 2 in place of x. So we'd have negative 2 squared plus 4 times negative 2 minus 5. And again, we could just put that into the calculator just to save some time. I'll tell you that gives me negative 9. So our vertex is going to be negative 2, negative 9. That goes in the middle of our table. Then let's look for another point. Well, another easy point we said was the y-intercept. The y-intercept is our c value. So at 0, negative 5. So what side should this one go on, the right or the left? Well, 0 is more than negative 2, so let's put it on this side. And there's a number that lives, an integer that lives between negative 2 and 0, so I'm going to put the 0, negative 5 right here. That means I can fill in negative 1. And again, to find the value, the y value, we just put negative 1 into that equation. So negative 1 squared plus 4 times negative 1 minus 5. Again, for time's sake, I'll tell you that's negative 8. So let's plot these points. Negative 2, negative 9. Negative 1, negative 8. And 0, negative 5. We can get the other points by reflecting it. The vertex reflects onto itself. This was half a box away, so we'll reflect it over another half a box, which is 1 whole unit. This was 1 whole box away, so we'll reflect it over the axis of symmetry, 1 whole box or 2 units. And here's our graph. Now, some of us just, when we connect, just connect with a U shape. But one thing is that the x-intercepts are important parts of our graph. So what we really should do is we should try to extend these so that they touch the axis. So let's extend this up so it touches the x-axis. Okay, so instead of a little graph that looks like this, isn't that much nicer? So that's why we have as many points as possible. Okay, and that's a beautiful graph for example 2. Then it asks, what are the solutions of x squared plus 4x minus 5 equals 0? Well, the only thing that's different is that the y is replaced with 0. So once again, let's look at the x-intercepts. Okay, so well, our x-intercepts are at, well, we're kind of estimating, aren't we? But it looks like my x-intercept was at negative 5, 0. And it looks like I have one at 1, 0. So that means that our solutions would be at x equals negative 5 and at x equals 1. If you're not comfortable with saying it's exactly equal because you're not sure, since you're guessing, you could put approximately equal at this point, and I'm okay with that. But that's it. So we just look to see where it crosses the x-axis. Those are the solutions. Okay? Let's try another one. In this one, we can again start by finding our axis of symmetry by using negative b over 2a. So I have negative 4 over 2 times 1. That'll end up giving us negative 2. So our axis of symmetry is at x equals negative 2. To find the y-coordinate of the vertex, we're going to put negative 2 in place of x and evaluate. And again, once you put negative 2 in place of x into this equation, you can put that into the calculator. I'll tell you that we get 2. So our vertex is at negative 2, 2. We'll put that in the middle. What's the next point we should find? That's right, the x-intercept, or the y-intercept rather. And we can see that our y-intercept is going to be at 0, 6. And 0 is above negative 2. So I'll put the 0, 6 right here. So that between, I can put negative 1 and find what that value is. So if I put negative 1 in for x, negative 1 squared plus 4 times negative 1 plus 6. Again, I can just put that in the calculator, and I find that y is 3. So let's put our axis of symmetry on the graph at x equals negative 2. Plot our points, negative 2, 2, 1, 3, and 0, 6. Now we can reflect over the axis of symmetry to get other points. So here, the vertex reflects onto itself. This will reflect one to the left of the axis. This one will reflect over 2 to the left. And we can connect those points. Now we said we would want to extend to intersect the x-axis, but we're going upward, so we won't do that in this problem. So then what the heck are we supposed to say when it asks us for the solutions of x squared plus 4x plus 6 equals 0? In all the other problems, we were looking for the x-intercepts. Well, there are no x-intercepts. What do you think that means about this equation? If you said it means there's no solution, you're correct. If there are no x-intercepts of our parabola, that means that there's no, I should say, no real solution that we have, since our coordinate plane is just the real numbers. So if it doesn't cross the axis at all, even if you keep extending, then that equation, that corresponding equation, has no solution. Okay? So that's it. No, so notice the only new thing we did was take the graphs that we made and look at the x-intercepts and recognize those as the solutions of the equation when the y is replaced with 0. That's it. Okay? Now, another thing you have all the pieces of, it's just asked differently, is we've been looking at minimum or maximum values. All right? We know that a function has a minimum value when it opens upward and a maximum value when it opens downward. And we know that it's the y-coordinate of the vertex. So that means that we need to find the vertex in each of these cases and then look at the y value. So that's the thing. All this is asking you to do for the min and max is to find the vertex. But we just list the y-coordinate as the solution. Okay? So before we find the vertex, we usually find the axis of symmetry, right? The axis of symmetry is the x-coordinate of our vertex. So let's find our axis the x-coordinate of our vertex. Negative b over 2a. So negative 24 over 2 times 3. That gives me 24 over 6, which is 4. That's the x coordinate. We want the y coordinate. So for the y coordinate, we'll have 3 times 4 squared minus 24 times 4 minus 5. Again, we just put 4 in place of x to find the y coordinate of the vertex. That's all we're doing. And when you, again, you can put that right in the calculator, and what you get is you get negative 53. So what that tells me is that the vertex is at 4, negative 53. So first, we have to decide if it's going to have a min or a max. Well, let's look at this. Our a value is positive, so it's going to open upward. That means we're going to have a minimum. And the minimum value, again, is the y coordinate of our function. So the minimum is negative 53. That's our answer. So it's really just finding the vertex, just like we had in other problems. And once you know the vertex, but depending on the direction it opens, you know if it's a min or max, and then the value is the value of the y value is the value of the min or max. Example 5. Let's start by, since it's asking for the min or max, let's start by finding the vertex. So we want to do negative b over 2a. Well, notice that there's no term with x, so that's going to be negative 0 over 2 times negative 2. That's just going to give me 0. And so then for my y value, I just put 0 in place of x. And this one, even without a calculator, most of us can probably tell that this is going to give us 1. So our vertex is at 0, 1. We use that vertex to tell if it's what the minimum or maximum value is. Our a is negative. That means it'll be opening downward. When it opens downward, that means that there's a maximum. And the maximum value is that y coordinate. So we have a max of 1. Same thing, example 6. We can find our x coordinate by using negative b over 2a. When I simplify that, my x value is negative 1. Then we just find our y value by putting that x value into the equation. So this process of using negative b over 2a and then substituting that x value in is just real crucial, as y'all can see. And when we do that, we end up getting negative 9. So our vertex is negative 1, negative 9. So which way does this open? Up. So is that a max or a min? It's a min. And what will the minimum value be? The minimum value is that y coordinate of the vertex. Okay? You got it? Do one more just in case. So here, y equals negative 6x squared plus 12x plus 5. It wants the min or max. Let's find the vertex, because that's going to tell us the min or max value. So we have negative b over 2a, negative 12 over 2 times negative 6. That's negative 12 over negative 12, which is positive 1. Now I can put that positive 1 in place of x. So I can find the y coordinate of the vertex. And that ends up being 11. So the vertex is 1, 11. Let's look which way this opens. The a is negative, so it opens down. That means I'll have a maximum. And the maximum value is the y coordinate of the vertex of 11. So notice we only give the y coordinate of the vertex, not the whole vertex, but just the y coordinate in our final answer. Okay? That can be extended to story problems. This is asking what the, so this says the storage building shown can be modeled by the graph of this function. So actually that shape can be modeled by y equals negative 0.12x squared plus 2.4x, where x and y are measured in feet. It says, what is the height h at the highest point of the building? Well, the highest point of a parabola is called the vertex. So this highest point, this really wants the vertex to help. And the highest point, notice the height is the y. So again, it's really asking for the maximum. That's really what this question is saying. It's really saying find the max, which we know how to do. So what we could do to find the vertex is find the x value by taking negative b over 2a. So we'll take negative 2.4 over 2 times negative 0.12. That gives us negative 2.4 over negative 0.24. Hopefully you trust my math here. And when we divide, that gives us x equals 10, which we can see here. And I know the picture verifies it, but I want us to practice the algebra in case they don't give y'all a picture, okay? So the x is 10. Now we just put the 10. Oh, I already wrote y equals. So we have y equals negative 0.12 times 10 squared plus 2.4 times 10. And we can put that in our calculator and we get 12. So our vertex is 10, 12. And look, that matches the vertex in the picture. But again, if they didn't give you a picture, we're able to do it using negative b over 2a. And so what is the height h? Notice the height is the y value. So the height then would be 12. And this is measured in feet. And that's your answer. Okay. Well, that's the bell. That means that it's time for you guys to come to class. And it means it's time to wrap this up. This will be up on the website. I know I went fast, but I was kind of under a time crunch here, as you can hear by the bell. But you have all the pieces of the graphing from the other day. The only new thing is making the connection between the x-intercepts and solutions, and then understanding that to find the maximum, you're just finding the vertex like we practiced before, and then just giving the y-coordinate. And we've done that in other forms also, okay? So hopefully that was enough to get y'all started on the homework. Thanks, and we'll see you guys soon.